Hello viewers, this video is about three-phase voltage source inverter operated in 120-degree mode with star connected load. The circuit of the three-phase inverter is shown, which consists of six switches with 6 diodes connected in anti-parallel. The load is connected in star phase. The switches are numbered in the order in which they are triggered, which means if S1 is triggered initially, after 60-degree interval S2 is triggered, then S3, then S4, then S5, and then S6. In 120-degree conduction mode, at any point of time, there will be two devices in conduction, whereas in 180-degree conduction mode, at any time, three devices will be in conduction. And in 120-degree mode, each device will be in on condition for 120 degree. But in 180, each device will be in on condition for 180 degree. There are 6 modes. Mode 1, the interval of mode 1 is 0 to 60 degree. During that mode, S1 and S6 will be in conduction, and mode 2 will be from 60 to 120 degree. And in that mode, S1 and S2 will be in conduction. Mode 3 is from 120 to 180 degree interval. During that, S2 and S3 will be in conduction. Mode 4 will be 180 degree to 240 degree, during which S3 and S4 in conduction. Mode 5 is between 240 to 300 degree. S4 and S5 will be in conduction, and mode 6 is from 300 to 360 degree interval, and during that mode S5 and S6 will be in conduction. Let us see mode 1, during which S6 and S1 are in the on condition. So we can see here that S1 and S6 are in on condition, and S1 is connected to the A terminal of the three-phase load, and the B terminal of the load is connected through S6 to Vs. So we can redraw this circuit as given in the right side. So A terminal is connected to the positive terminal of Vs, and B terminal is connected to the negative terminal of Vs, and C terminal is now kept in open. So we can write the voltage Vs is divided between A and B terminals. Between A and B terminals, we have the A phase load and the B phase load, which are connected in series. So the voltage Vs is divided into two equal parts. And since A is connected to the positive of Vs, Va naught is equal to Vs by 2 plus Vs by 2. And since B is connected to the negative of Vs, Vb naught is equal to minus Vs by 2. And Vco is 0. Now let us see mode 2, during which S1 and S2 are in the on condition. The load terminals A and C, they are connected to the source. A is connected to plus of Vs through S1, and C is connected to the minus of Vs through S2. And B terminal of the load is kept open. So we can see here that A terminal is connected to plus Vs, and C terminal is connected to minus Vs. So we can write Va naught equal to Vs by 2, Vc naught is equal to minus Vs by 2, and Vb naught is equal to 0. Now mode 3 is considered here. In mode 3, S2 and S3 are in the on condition. The A terminal is now kept open, V terminal of the load is connected to plus of Vs through S3, and C terminal is connected to minus of Vs through S2. So we can write Va naught equal to 0 since A is open, and Vp naught is equal to plus Vs since B is connected to plus of Vs, and Vc naught is equal to minus Vs by 2. Vb naught is equal to plus Vs by 2, and Vc naught is equal to minus Vs by 2. Now this is mode 4, during which S3 and S4 are in the on condition. And the A terminal, it is connected through S4 to minus of Vs. P terminal is connected through S3 to plus of Vs, and C terminal is kept open. So we can write Va naught is equal to minus Vs by 2, and Vp naught is equal to plus Vs by 2, and Vc naught is equal to 0. And this is mode 5, during which S4 and S5 are in the on condition. A terminal is connected to negative of Vs, negative terminal of Vs through S4. B terminal is kept open. C terminal is connected to the plus of Vs through S5, so which is drawn on the right hand side of the diagram. Since C terminal is connected to the plus of Vs, we can write Vc naught is equal to plus Vs by 2, and A is connected to the minus of Vs, so Va naught is written as minus Vs by 2. Since B terminal is kept open, Vp naught is equal to 0. Then we have mode 6, during which S5 and S6 are in the on condition. Here A terminal is kept open. B terminal is connected to minus of Vs through S6. C terminal is connected to plus of Vs through S5. So we can write Va naught is equal to 0, Vp naught is equal to minus Vs by 2, and Vc naught is equal to plus Vs by 2. Now let us see the waveforms of the different voltages Va naught, Vp naught, and Vc naught, which we have obtained during the 6 modes of operation. So Va naught is equal to plus Vs by 2 for mode 1 and mode 2, and it is equal to 0 for mode 3. The Va naught is equal to minus Vs by 2 for mode 4 and mode 5, and it is equal to 0 for mode 6. Similarly, we have obtained Vp naught is equal to minus Vs by 2 for mode 1, and for mode 2 it is 0. For mode 3 and mode 4 it is equal to plus Vs by 2, and this is Vp naught is equal to 0 for mode 5, and it is equal to minus Vs by 2 for mode 6. Then Vc naught is equal to 0 for mode 1, and it is equal to minus Vs by 2 for mode 2 and 3, equal to 0 for mode 4, and it is equal to plus Vs by 2 for mode 5 and 6. So the entire set of waveform is again drawn for the next cycle of operation. From these waveforms, that is Va naught, Vp naught, and Vc naught, which are all the phase voltages, we can obtain the line voltages VAB, which is nothing but Va naught minus Vp naught. So VAB can be drawn by subtracting Vp naught from Va naught. So for mode 1, Va naught is equal to plus Vs by 2, minus of minus Vp naught will be equal to plus Vs. And in mode 2, Va naught is plus Vs by 2 and Vp naught is 0. So this minus 0 will give you plus Vs by 2. And for mode 3, Va naught is 0, Vp naught is plus Vs by 2. So 0 minus plus Vs by 2 will be minus Vs by 2. Then for mode 4, Va naught is minus Vs by 2, and Vp naught is plus Vs by 2. So minus Vs by 2 minus Vs by 2 will give you plus V minus Vs. Again for mode 5, Va naught is minus Vs by 2, Vp naught is 0. So minus Vs by 2 minus 0 will be equal to minus Vs by 2. For mode 6, Va naught is 0 and Vp naught is minus Vs by 2. 0 minus of minus Vs by 2 is equal to plus Vs by 2. Again, we can get the same set of waveforms for the next cycle. Similarly, we can get VBC equal to VB naught minus VC naught, and VCA can be obtained as VC naught minus VA naught. Now we can express the Fourier series expansion of the output voltages. Here we have obtained the Fourier series expansion of the phase voltages Va naught of omega t, which is equal to sigma n is equal to 1, 3, 5 to infinity 2 Vs by n pi cos n pi by 6 sin n omega t plus n pi by 6. Vb naught will be equal to sigma n is equal to 1, 3, 5 to infinity 2 Vs by n pi cos n pi by 6 sin n omega t minus n pi by 2. And Vc naught is equal to sigma n is equal to 1, 3, 5 to infinity 2 Vs by n pi cos n pi by 6 sin n omega t plus 5n pi by 6. All these expressions are derived by using the phase voltage waveform and applying the Fourier series expansion. Thank you.